Today's video starts on page 39. It's the problem of the day. I would bar model this would be a good hint. First cutting it into sevenths and then each of those parts into sixths. My denominators tells me how to divide it up. That might help you figure out the answer to this problem. So give it a shot, bar model it, I think is the best way to go, and do this on your own. Pause the video. We'll go over this tomorrow in class. We are still working on our distance equals rate times time, or distance equals speed times time formula. Some people call it D equals RT. Sometimes you'll see it as rate of speed, ST. Speed times time equals distance. Mr. Anthony drives his truck at a speed of 45 kilometers per hour. At this speed, how far does he travel in 2 hours? Well, in 1 hour is 45, so 2 hours multiplied by 2, and you would get 90 kilometers. At this speed, how far does he travel in 5 hours? Again, take your 45 kilometers per hour multiplied by 5, and you would get 225 kilometers. A racing car can travel at a speed of 175 kilometers per hour. How far could the racing car travel in 3 hours? Well, we could bar model it. 1 hour is 175 kilometers. So 3 of those bars would equal 525 kilometers. Or just do the mathematics of distance equals speed times time, ST. So 175 times 3 would give us the car can travel 525 kilometers in 3 hours. Next page. A high-speed train can travel at a speed of 65 meters per second. How far can the train travel in 2 seconds? Well, if it's 65 meters in 1 second, to get 2 seconds, just multiply by 2, right? And you would get 130 meters, make sure you're labeling this, per second. Find the time given the distance and the speed. So now we're using our formula and we're solving it for time, which is equal to distance divided by speed. And there's the formula. Time equals distance divided by speed. And you can see in the little triangle, the distance, there's the fraction line divided by speed. Lucas ran around a field at a speed of 8 meters per second. How long will it take him to run a distance of 96 meters? Well, taking that 96 and dividing it by his distance and dividing it by his 8 meters per 1 second, it would take Lucas 12 seconds to run 96 meters. Taking our formula, we could take our distance and divide it by speed, which is 96 divided by 8, which will give you 12 seconds. The distance between city X and city Y is 216 kilometers. Mr. Thomas rides his motorcycle at a speed of 54 kilometers per hour. So there's my speed. Here's my distance. How long does it take him to travel from city X to city Y? Well, in my triangle, time is equal to distance divided by speed, right? So time equals distance divided by speed. My distance is 216. My speed is 54. So when I divide those, I get 4 hours. So it would take Mr. Thomas 4 hours to travel 50, if he's traveling at 54 kilometers per hour, to go that 216 kilometers. Find the average speed to solve real-world problems. The speed an object is traveling over a distance may not be the same for the entire time. Very hard to maintain constant speed. You know, when you're driving on a bicycle, you may speed up or slow down. As you're going up a hill, you probably slow down. As you go down the hill, yay, you get more speed going down the hill. When you're in a car, you know that your parents have to come to a stop at a stop sign, or traffic slows up suddenly. and you have to slow down. You're not going that 55 miles per hour. You slow down to like 40 because there's a lot of traffic, or you got to change lanes. So it's very hard to go an exact speed for a certain amount of time. Post A and post B are 9 meters apart. Post B and post C are 21 meters apart. A bicycle travels from post A to post B in 2 seconds. Then it travels from post B to post C in 3 seconds. Find the average speed of the bicycle for the distance from post A to post C. The speed between post A and post B is different from the speed between post B and post C. So to find the average, take the total distance and divide it by the total time. So the total distance, the 9 and 21 makes 30. The total time, 2 and 3 makes 5. So taking our 30 and dividing it by 5, we get that the average speed of the bicycle is 6 meters per second. Now remember, speed is a rate, so you have to have both labels on rates. Meters per second. Next page. The distance between town P and town Q is 80 miles. Okay, I'm going to draw a picture here to help. The distance between these is 80 miles. And the distance between Q and R, so then going Q over to R, that distance is 320 miles. A van takes 2.5 hours to travel from P to Q and 5 hours to travel from Q to R. Find the average speed. So we've got to get our total distance divided by our total time to get our average speed. Remember our triangle. Now we're solving for speed, which is equal to distance divided by time. So speed is equal to total distance divided by total time. Well, my total distance, 80 plus 320, is 400, and my total time is 7.5. 400 divided by 7.5 gives me 53.333333, or I'm going to change it to the fraction 1/3. You know, we would probably round that to 53 miles per hour. But, it is 53 1/3, so I'm going to leave it at 1/3. 0.3 repetent is equal to 1/3. So I changed that 0.33333 to 1/3. And the last problem. Celia ran around a 400-meter track 2 times. 400-meter track 2 times. So I'm going to multiply that by 2 to get 800 meters. It took her 4 minutes to run around the track once and 6 minutes to run around it again. So her total time is 10 minutes. So find Celia's average speed. Speed is equal to total distance divided by total time. Total distance is 800 meters, and my time is 10 minutes, right? 10 minutes. Forgot that in there. So her average speed is, well, it's easy, 80 meters per minute. 80 meters per minute. And that's it for today's video.